Hello. So our today's question is, if fx equals to 4x by 3 upon 6x minus 4, where x cannot be equal to 2 by 3, then show that for f of x equals to x, and for all x cannot be equal to 2 by 3. We also have to write the inverse of f. Or the other question being, to check if a relation R in the set of R real numbers is defined as R equal to A comma B, where A is less than B, if this relationship is symmetric or if it's transitive. Coming to the next slide, we have to find f of fx. That means that f of fx, right? You can see the notation. Now, we know that fx equals to 4x plus 3 upon 6x minus 4. So we've put that function in the f function. Then instead of putting x in every situation, we have put the function of x. Then we've just solved it and we got our answer as x. Now let's see. To find the inverse of f, what we did is we took y equals to fx, which is simple. Then we changed the function to make it a function of y. So we have displaced it everywhere and took x on the left hand side and made a function of y. Now, if fx equals to x, fx equals to y, then x equals to f inverse of y. Right? So, we found the x. So that means that f inverse of y is that function, which is also f of y. That means inverse of f is also f. In this slide, we were given our relation to be a less than b for all a comma b belonging to R and ordered pair of a comma b belonging to R. So now let's consider a is less than b. That does not imply that b is also less than a. So if a comma b belongs to R, then that does not mean that b comma a also belongs to R. Hence this function is not symmetric. In the next part, we have to check for transitivity. Here a comma b comma c, all of them belong to R. So if a comma b belongs to R and b comma c also belongs to R, which is a is less than b and b is less than c, that means that a is less than c. So hence a comma c belongs to R and it is transitive.